Do you have that expectation? Bakit nga ba pag-aaralan mo kasi engineering materials? Or anyone? Mr. President, why the need to study? Why the need to study engineering materials? Or better yet, what's your expectation of this subject? Hmm? Ano pa? Do you have any idea what's the difference between materials science and materials engineering? And anyone? Mag-graded recitation na ba ako? Anyone who knows the answer? Okay, ano lang. Sige, very easy question. What's the difference between chemists? What's the difference between a chemical engineer and a chemist? A BS Chem graduate and a BS Chemical Engineering graduate. Hello? Hindi nyo alam anong difference nyo kay chemist?
Ma'am, pag chemist po ata is dun po sila sa laboratory skill while po yung chemical engineering po ma'am is yung laboratory skill po is parang papalaki, i-upskill po nila into commercial skill, ganun po.
Pag chemist, again, if it is a chemist, you just stay in the lab. Ganun ba yun?
Hindi
Mr.
naman po ma'am.
Ano din?
Yung usually po ma'am is parang more on yung reactions, gano'n po ma'am in that takes place in the lab, usually mga gano'n po. Samantalang pag yung chemical engineering po ma'am is parang kung whatever takes place in the lab ma'am, parang magde-devise sila ng plan or basta papalakihin po nila yun para magamit into commercial, gano'n po.
Okay, upscaling. What if I say to you right now that I head the lab and I am a chemical engineer? Would you say that I am not putting into use what I've learned in my profession? Hindi ako chemist, pero I head the lab. Actually, I have quite an extensive um, experience in the lab because way back 2016, I left the university. I don't know if alam niyo yun. I just got back sa CSU last 2018. I worked in one of the banana exporting industry in Davao and I had the chemistry laboratory of that company. But I am a chemical engineer. But I'm not a chemist. But under me are 9 chemists and some microbiologists. O, di ba? Medyo contradictory na yun kung sasabihin mo sa akin na ang chemical engineer are putting into or upscaling what the chemist is learning also in the lab, na parang laboratory reactions yung alam ni chemist. Possibly, but still, chemical engineers are also lab rats. Tawagin. Okay, are there any more reaction or answer to that question before we proceed? Pwede. Pwede. Pero basically, our difference with a chemist, actually they do the analysis and we can do that also. But then our difference is that our knowledge on R&D is much deeper than them. Especially like when it comes to industrial applications then, what else? Yun, yung kanina sinabi niyo, upscaling, pwedeng work din yun ng isang chemical engineer that a chemist cannot actually do. But 2 years ago, 2, 3 years ago, because of the passage of the chemistry law, na-encroach yung work natin as chemical engineers in the lab. Right now, chemical engineers cannot sign test certificates for public use. We can only sign test certificates if it is within the company. But if it is for public use or it's a public document, chemical engineers cannot sign. That's why some of the chemical engineers are actually taking ChemTech for the exam, just for them to still stay in the lab. But then even if the chemistry law is stating that laboratories must be head by a chemist, if the laboratory is an R&D, say for example, in my case, the Central Analytical Lab is actually a service lab, but at the same time, it is also the Tuklas Lunas Development Center, which is a research laboratory. A chemical engineer can be the head of the laboratory. Okay? Now we continue with what a material science and materials engineering is. So asking the why materials science? I can hear an echo. Why is that? Okay, no more. So what is the relationship between material science and materials engineering? So just like any profession, there's actually a delineation between the two. But there is also a collaborative or there's a relationship between the two. One cannot outdo the other in that case. So let's take a look first at the history. So why materials? Definitely, virtually every segment of our everyday lives is influenced by materials. For example, right in front of you, the computers, the cell phones, even the clothing that you're actually wearing right now are influenced by materials. And materials of prehistory are all naturally occurring. Kaya nagkaroon tayo before ng Stone Age, uh, definitely hindi sino Ice Age, Stone Age, di ba? Iron Age, the stone, wood, clay, skins. These are actually the challenge of that era lies on shaping these materials to produce valuable and working material. So kung sasabihin mo, oh, those that belong to the Stone Age, definitely their tools or their materials are all out of stone. Okay, and then early civilizations have been designated by the level of the materials development. Right now, you are Gen Z. I don't know if we could call this as your AI. Is it already an AI age? Artificial intelligence age? Kasi hindi na 90s pa siguro pag sasabihin mo na it's the internet age or yung IoT na ngayon and then the AI. Before, at least you're still lucky that you haven't lived during those age na Stone Age or Bronze Age. Though siguro, life is much simpler during those times because your only concern is just to eat and live, right? Eh ngayon, meron pa kayong math, meron pa kayong materials na inaaral, right? May design, may FIChem. Noong unang panahon, wala lahat yun. So earliest humans have limited materials to access to. This is stone, wood, clay, skins. And now, there are new materials developed and processes and knowledge that are being exploited. So material selection is becoming difficult as tens of thousands of materials are now available. And take note, the development of thermochem and later of polymer chemistry enabled the development of man-made materials. So you imagine that before We don't have any, parang aluminum was first established as an engineering material only in the 20th century. And now there are thousands of aluminum alloys. So with ever increasing drive for performance, economy, and efficiency, and the imperative to avoid damage to our environment, because definitely we are gearing toward the age that we need to protect our one and only earth, right? So remember, slowly green engineering, the SDGs are actually embedded in the learnings as early as elementary or high school. They're still also talking about SD, yung sustainable development. Industries right now are talking about recipe, yung resource efficient, cleaner production. So that's our track at this time, because we have seen the degradation, we have experienced all natural calamities, catastrophes in the past years, and that's why everyone is actually involved in taking care of the only planet that we have. So it all boils down to making the right choices, and it becomes very important. And innovative designs mean imaginative exploitation of the properties offered by materials without compromising the environment. Okay? Now let's study what's the uh, connection, what's the interrelationship between material science and materials engineering. We take a look. Material science involves the investigation of the relationship that exists between the structure and the property of a material. So this is more or less on a microscopic to semi-macroscopic level. Whereas a materials engineering or engineering materials, it involves the processing of the material to produce a predetermined set of properties for better performance. So it's like you need to study the structure and the property so that you would know the processing, so that you could alter this structure and alter the property for you to be able to attain your predetermined goal of having a better performance of the material. So it's like uh, a successful product is one that performs well. It's a good value for money. It's always definitely economics is there to consider. And that the mother of all inventions would be to give pleasure or to give us a comfortable lives and fully exploit the potential and characteristic of a material. So engineers makes things and they make it out of materials. And the materials that have to support loads, like to insulate, to conduct heat and electricity, to accept or reject magnetic flux, to transmit or reflect light, to survive in hostile surroundings. So this term about corrosion and degradation, and to do all this without the damage to the environment and having not costing too much. So it's always a trade-off between what you want, but at the same time, a quality of the material that you would want at a lesser price as much as possible. And to make something out of material, you need definitely a process, but not just any process, right? This one. So it involves us engineering. We are the ones designing. Do we need to increase heat treatment? Do we need to increase its mechanical strength by altering the structure and then altering the properties so that it uh, gives you a harder material? So those actually are the things that you need to consider. So as that your material will be compatible. So definitely, it's always a marriage between the process and the materials, and compatibility is always the key. Just like in any marriage, definitely kung meron kang boyfriend or girlfriend, you won't last if you are not compatible. So um, remember that. So in engineering materials, our aim actually is to find the correct process for a certain material. We are like, say, matchmakers to provide methods and tools to ensure a happy and a durable Yun yun. So parang it's always what do you call this? It's always the interrelationship between the structure, the property, the processing, and the performance. Well, your ultimate goal is really always boils down to the better performance of the material that you would want to produce. Definitely, you wouldn't want to create or invent a material that is of lesser quality, lesser performance than what is in the market. Otherwise, you won't sell that product, right? Okay. So material science and engineering is actually a relationship between the processing, the structure, which relates to the arrangement of the internal components, subatomic, atomic, microscopic, and the macroscopic level, so that you would have a property of the material, which is that's the trait in terms of the kind of magnitude of response to a specific imposed stimulus. Parang, if I'm going to hit this polymer, definitely at a higher temperature, it will melt. So that's actually the response. The melting is actually the response of the material to the external stimulus. That's the heat treatment that you impose to that material. So whatever is a response, that's actually a property of a material. So that would have, of course, a better performance. So these are the four components of the discipline of materials science and engineering and the linear interrelationship. Okay, so we proceed. So it's actually the picture that I'm showing to you right now is of the same materials. So it's like this one is an aluminum oxide. Is it clear that the one on the left is very transparent? The one in the middle is a bit translucent, and the third one is opaque. Though these are made of the same material, it's still aluminum oxide. But take note that this thing here on that is very transparent is a sapphire. When you say it's a sapphire, it's a single crystal material. So if it is a single crystal material, all the lights that pass through it is being just it passes through the single material. That's why you could see the letters behind it. So it's like it is transparent. The second one is still it's aluminum oxide, but then it is fully dense. So parang it has 5% porosity. When it has 5% porosity, some of the light that passes through that material is being refracted. Kaya nagiging translucent. Now, the third one, the rightmost button here, is still aluminum oxide, but this time it contains so much porosity. That's why it is opaque. Or the light that passes through it cannot, actually the light that is being transmitted cannot pass through it. It's all reflected back. That's why it is opaque. Okay, so note the difference. We have the same material. What did I alter? Anyone? What did I? It's the process. It's the heat treatment process. At a very high temperature, I could come up with a single crystal or a fully dense or the one that is very porous. Okay? But still, sabi ko, di ba, it's the same material, same property, pero because of the alteration of the process, I was able to come up with a product of different property and of different performance. Okay? Another. I'll show you. This one is one of the projects that I was able to engage in when I was doing my MS. This is a project of the Material Science Division of the ITDI in the OST. So this same material, which is out of Pinatubo porcelain, when you they have the same shape, it is actually molded into a beautiful lady here. But this one, the leftmost figurine, was just heat treated up to 1,200 degrees. That's why if you could see, the light cannot pass through it. So it's like um, uh, opaque. The second one is the same thing, pinatubo porcelain, but the heat treatment is at around 1,250 degrees Celsius. It, some of the light can pass or it's a bit translucent. Whereas further heat treatment up to 1,300 degrees and beyond of the pinatubo porcelain, nakita nyo, kitang-kita yung light. So the picture here shows the pinatubo subjected to different heat treatment. So higher temperature produces porcelain with higher light transmittance. So same as the aluminum oxide button that I've shown you a while back. So just after the processing, after the heat treatment, you produce a product of different property. Okay. So why study engineering materials? Again, the question. Okay. First, the very first reason is, of course, we'd want to study engineering materials to select the right material. So seldom does a material possess the best combination of property. Rather, there is that optimum which trade off one characteristic for the other. It's like, of course, we don't have any ideal material. So all important properties of solid materials may be grouped into 6 categories. Would have, by selecting the right materials, you need to consider those 6 categories: the mechanical property, the electrical property, thermal, magnetic, optical, and degradation, or the response to deterioration. Now, for each of these category, there lies a characteristic type of stimulus capable of provoking a different response. How is that? Say, for example, if I would consider a mechanical property of a material, it relates, diba? When you say mechanical property, it relates to deformation to an applied load or force. That's what you learn in physics. Have you taken physics already? Yung physics of deformable bodies? Tapos na kayo? Or physics in your high school, right? It is from that subject that you are able to encounter the word modulus of elasticity, strength. Are you familiar? Uy, hello. Andyan pa ba kayo lahat? Or I'm just talking to no one anymore? Familiar kayo sa modulus of elasticity? Oh, no one answers me. Are you still there?
Yes po,
So familiar kayo doon sa modulus of elasticity? Is my presentation moving at your end? Baka mamaya, katulad nung nangyari last time, na-stop o nag-lag yung presentation ko at the end of the students. Are you with me at slide 28?
Yes, ma'am.
Okay, good. Sige. Wait, parang merong nagpapa-exit. Okay. So we go back. I was talking about a while back about the mechanical property of a material. Next is electrical. When you say electrical, it is actually the stimulus or your response. The response of the material would definitely take into account the electrical field being applied to it. And those properties can be measured through its electrical conductivity, dielectric constant, etc. When we talk about thermal, the thermal behavior of solids can be presented in terms of your heat capacity and thermal conductivity. Definitely this will be, have you taken your thermodynamics? So medyo familiar na siguro kayo doon, right? Mga thermal conductivity, heat capacity of a certain material. When we talk about magnetic, it is actually it demonstrate naman the response of material to the application of magnetic field. Kaya nga, magnetic. For the optical, the stimulus is electromagnetic or light radiation. A while back, I've shown you materials that are a bit translucent, transparent, and opaque. So that property can be measured in terms of index of refraction or index of reflection, or we call it as reflectivity. And last property, the category of the material, it's the category of the material that has something to do with its response to external stimuli is its deteriorative property. This relates to the chemical reactivity of the material. Okay, going back to the selecting of the materials. When you need a packaging material for soft drinks, say Coke, you do not just recommend a glass, right? So you're familiar with the glass packaging of the Coke, the aluminum, and the PET bottle. The very first packaging that was utilized by Coca-Cola is, of course, that of a glass. It is strong, it is transparent, but it's quite heavy. And then other materials were developed and could be good enough and has other better properties that meet the needs of the consumers. For example, I am showing to you right now the different packaging materials for that beverage. So before, Coke is packaged in a glass bottle. The biggest so far is actually a 1 liter. Nadatnan nyo pa ba yun? Yung litro
Yes po.
na
Yes, ma'am.
napaka pa. Okay. So,
Yes.
magka-cage lang pala tayo. So, kala ko ako nila nakaabot nun. Napapaghalata eh. Okay. And then, here comes the metal aluminum. Usually, nakikita nyo to sa mga convenience stores, right? Definitely, baka hindi kayo makahanap ng soft drinks that is being packaged in a glass bottle in convenience stores. Mostly, it's either using PET bottle or a metal aluminum. Okay. Of the three packaging materials, there are properties that are being considered. One is, if I am to choose a packaging material for the soda beverage, it should provide barrier to the passage of carbon dioxide, right? Which is under pressure inside the container. Why? Kasi if there is a passage of carbon dioxide, after a while, mawawalan ng fizz or your soft drinks would taste flat. Have you experienced drinking a soda, then you just left it on your glass, and then after a while, hindi na siya masarap. Mukha na lang siyang juice na matamis.
Yes po, ma'am.
Right?
Yes.
Because all of the carbon dioxide has escaped already. Tama? Maiiba na yung lasa niya once the carbon dioxide is depleted. Diba? Kaya ang tawag natin sa kanila is it's a carbonated drink. Kasi if it doesn't contain carbon dioxide or if it is not carbonated, juice na lang yung kinalabasan niya, right? So that's the first consideration that you would need to meet if you are to choose a packaging material for your soda. Diba? It must provide a barrier to the carbon dioxide. Second, it should be non-toxic and unreactive with the beverage that you're going to pack, and preferably recyclable. Diba? Kasi if it is toxic or if it is reactive with the acid of your beverage, and definitely it becomes also toxic to the one who's drinking the beverage. So you already violated food safety. So aside from non-reactivity and non-toxic, you would prefer a packaging material that is easy to recycle. Diba? Hindi yung isang gamit tapon. That's why I don't know if you've experienced also buying a liter of Coke in glass bottles that you have to give a deposit. It is actually for the consumers or to force the consumer to bring back the bottle to the store. Diba may deposit ganon? Para lang kayo balik na yung bottle. It's
Yes po,
actually
ma'am.
a marketing strategy of the producer, so that they would actually didn't want to always produce glass bottles. They would want to recycle, either recycling it through, parang babasagin nila yan, then produce another glass container, or they would just wash thoroughly and then have it in a septic environment so that they could again use it as a packaging material. So that's the second. Third is, it must be relatively strong. Hindi pa dapat agad napopoke or hindi agad nababasag or hindi agad nasisira yung packaging material. And for most for business, it must be inexpensive. And the cost to fabricate that material, that packaging material, should be relatively low. So that four properties is still met by these three. The fifth one is if it is transparent, it must retain its optical clarity. Tama? Kung transparent yung iyong, let's say, the glass bottle and the plastic PET, the optical clarity must still be the same as the first day up to the time that the consumer would deplete the contents. Otherwise, alam naman makikita mo, okay, medyo dark after 1 week, pag hindi nabenta yung coke, naglalighten na. Di ba? Hindi pwede. Kung you have the cringe experience of first time, kasi ako, I was a bit parang adamant when I saw the Sprite in a clear PET bottle. Di ba sanay kasi tayo before that Sprite are contained in a colored PET. Nung biglang nilagay sa clear PET, para na lang feeling mo tubig na nasa ref, right?
Yes po, ma'am.
Yes, ma'am.
Di ba kung noon pag may puti sa ay alam mo tubig lang yan. Pag nakalagay sa clear PET. But there may be 1,000 or so reasons for these manufacturers to deviate from the colored PET to having the clear. Kasi one thing is that ever since ang Sprite naman iputi, di ba? It's colorless. Di ba nasanay lang tayo na siya sa colored bottle siya, but definitely it's colorless. Unlike the Mountain Dew. The Mountain Dew, di ba? Yan yung talagang may kulay. Okay? So the sixth property that should be met by a packaging material is that it can be adorned with decorative label. Kaya siyang maprintan ng label. Just like the glass bottle, the aluminum, the metal aluminum, right? Except for the PET. Si PET, you just need to print that in a certain paper and then pour it around the body of the PET bottle. However, diba, the ceramic glass, of course, dun sa transparency, hindi papasa si metal aluminum. But having passed those properties, what are the weaknesses of each and every packaging material that I'm showing it to you? One is, for glass, it cracks, right? And easily fracture. Pag binagsak mo yan, pwede mabasag, natapon what do you call this? Si beverage mo, si Coke mo. Si aluminum naman is relatively strong, but it can easily be dented, right? How about
Yes.
the aluminum and the glass retains carbonization? Take note that this, if I use the glass and the metal aluminum, it can retain its carbonization for several years. But for the plastic bottles, after a few months, it goes flat. Na try nyong i-compare that after a while, few months lang, iba na yung lasa nung nandun sa PET bottle. Meaning to say that although it provides the barrier or the passage of CO2, it has a shelf life, which is quite short compared to the glass and the metal aluminum. Now, my question is, what is the biggest advantage of having the metal aluminum? Of course, we know, si plastic bottle pala, I forgot to mention, the plastic bottle, its advantage over the two is that it is very lightweight. Have you seen, let's say, a 2 liters ba yung pinakamalaking beverage container? Have you seen a 2-liter container in a glass? In there, right? Because it's quite heavy. And definitely, it's not good to see a 2-liter beverage in an aluminum can. Kasi this one is actually for individual packs. Hindi siya po pwedeng, although sige, pwede rin naman siguro, pero di ba mukhang tanga lang. Having a 2-liter beverage or 2-liter Coke in an aluminum can. Now, can you give me what's the advantage naman of a metal aluminum can over the two, except that this is packaged for individual use. So aside from having individual use, among the 6 properties that I have mentioned a while back about optical, thermal, mechanical, magnetic, and all, what's the advantage of having an aluminum packaging for a soda drink? Anyone? Ano kaya ang advantage ng having a metal aluminum?
Yung thermal niya, ma'am.
Thermal? O ano ang tungkol kay thermal?
Mas mabilis po siyang dumami.
Good, very good. It can be cooled rapidly. Why? Because of the thermal conductivity of metals over glass and over plastics. Okay? So yun yung naging advantage. So that's why in convenience stores, ito yung mas choice na nabibenta. Except of course dun sa mga malalaki because of its lightweight packaging. Okay? So for now, at least you have already an idea of the trade-off between one characteristic of a material with the other. So it would depend on the need. So everything is basically, or everything, or every invention or every production is always market-driven. Kasi business yan eh, di ba? So why would you produce a product that is not well accepted by the public? Hindi, di ba? So it's always market-driven. It's always what's the customers or what the consumers want, so that you would always go back to R&D, develop the product, and again, market it. Okay? Next, so first is the selection of the right material. Second is, of course, deterioration of material property during performance. You do not want a material that would easily degrade during the in-service condition of the material. So if that desired application is at elevated temperature or in corrosive environment, you would want to choose a material that would withstand that external stimulus. Okay? And the most important of the 3 considerations is, of course, economics. Business is business. So sometimes the ideal set of properties for a given set of application results to prohibitive costs. So why would you want to produce a product that is, say for example, same quality or lesser quality than the ones already in the market, and then much expensive? So definitely walang bibili. People could actually pay for quality. If your quality is better than those in the market, even if your price is a bit higher than the ones already out there in the market, definitely your consumers would buy it at your product. Okay? So on only rare occasions does a material possess the maximum or ideal combination of properties. Sabi ko nga, there's always a trade-off between one characteristic over another. A classic example involves, of course, strength and ductility. There are material having high strength but would have a limited ductility, just like the case of the packaging for beverage, soda beverage. Diba? You'd always trade off one property over the other. So it depends on your need. Okay? Now we proceed with the different classification of engineering materials. So solid materials are grouped up to the late 80s in three. So from the start up to late 80s, tatatlo lang yung classification ng material. You'd always know it's metal, ceramics, and the polymers. And based on the chemical makeup and the atomic structure. But in the 90s, there's a new important emerging classification. Those that belong to composites, semiconductor, and biomaterials. Okay, so you have six. But wait, just recently, we have an addition to this six classification of materials, and we call that as your advanced materials, or sometimes they term it as smart materials. Okay, let's take a look at each of these classification. One is metal. It's a pure or combination of metallic elements or alloys. So electrons are free and not bound to particular atoms, and many of their properties depend on these free electrons. That's why they are good electrical conductivity, heat conductivity, strength, and they can easily be deformed. Diba? Thin sheets of metal can easily be formed into different shapes. So metals are considered mature materials. When you say mature materials, konti na lang yung development that you could do for that. What do you call this? The potential for breakthroughs for this. Areas of development are in higher operating temperature engines and turbines, and also in powder metallurgy. And gas na to, but in your chemistry, you've learned the metal forming elements. Diba itong mga clear dito? Because the one that is shaded are your non-metals, at yung mga kalakalahati na to as we call as your intermediate metals. Okay, so these are some of the materials that we use every day, which are made out of metals. Second is your ceramics. These are solid compounds formed by the application of heat, sometimes heat and pressure comprising at least. So ang ceramics can either be a metallic plus non-metallic, or combination of non-metallic solids, or we call that as NMES. So it can either be at least 2 NMES or 2 NMES plus non-metal. So usually it takes the form of oxides, nitrides, carbides, and borides. Examples of these are your clay materials, cement, and glass. So these definitely are non-metallic inorganic solids like porcelain or alumina. I think the one that I have on the presentation. It is stiff, hard, and abrasion resistant. It retains strength at high temperatures, and it actually resists corrosion very well. The third one is polymer. So actually, these are some of the ceramics. So development areas or that could be exploited still are those ceramics engines, superconductors, and electro-optic components. So these are your ceramic forming materials. Third is for polymers. So it constitutes a special branch of organic chemistry, meaning the word poly and the mer, so many chain, right? So common or layman's term for polymers are, we call it as plastics. They are lightweight, low cost, low strength, low melting point, higher chemical reactivity. And one advantage of polymers are that you can just pre-color the polymer, yung gagamitin mong polymer, you can just pre-color it with either whatever color you would want, whether red, yellow, black, or anything, so that it needs no finishing operations at all. So these are light, as I've said a while back, with a modulus of elasticity 50 times less than that of the metals. Though their properties depend. So all plastic, most of their properties depend on temperature. They are very brittle at -4 degrees, but very rubbery. Parang, ano ba yun? Diba pag hinit mo into 100 degrees Celsius, it will melt, but then medyo rubbery lang yung kanyang composition. Okay. So these are some of the polymers. Areas of the development in research are biodegradable polymers, the LCDs, electrically conducting polymers. And of course, you could do recycling of the polymers. The one that I'm showing to you right now are waste foam polystyrene, mga FPS. Like yung mga packaging materials sa mga TVs, mga computers ninyo, those are styrofoam, ang tawag natin, di ba? Because of environmental concern, you would notice na yung dating mga spaghetti nyo sa Jollibee na naka-styrofoam ngayon, hindi na. But one development that you could do for recycling of this waste foam polystyrene is that you could melt it using waste cooking oil. So hitting two birds with one stone. You're using a solid waste, and a liquid waste. So if you would melt this waste foam polystyrene in cooking oil, then have it be molded, you could come up with a tabletop like this, or pavement blocks or pots. Para sa mga plantito at plantita, it's very lightweight, but then you could put it into use. So these are some of the areas that you could do recycling for polymers. So these are the polymer forming materials. And then composites, number 4. It's a combination of 2 or more different materials. Very common yung fiberglass na tinatawag natin. Although it's actually not out of glass, because glass is actually under the material for plastics. It's term, actually a correct scientific term for that is a fiber reinforced plastic. Okay. Another type of a composite is, of course, a very common concrete. The 5th one, semiconductors. These materials have the electrical properties intermediate between an electrical conductor and an electrical insulator. So this made possible the advent of integrated circuitry that has revolutionized the electronics and computer industries in the past 2 decades. Before, palakihan ng computer, ngayon paliitan na, parang mas maliit na, parang you could just make thousands of bits in a very small area. So sabi nga yung kung noon palakihan, ngayon the scale of chips is from 1 million for a 486 chip to order of now of 100 million. So areas of development could also be through micro machining of these semiconductor materials. So ito yung naka-dark. These are your semiconductor forming materials. And the 6th is the classification is the biomaterials. Those are materials implanted to human body to replace human bones. Diba? Very familiar kayo that whenever you have met an accident, as pwedeng magkakaroon ka ng, what do you call this, fracture. Usually, lalagyan ka ng stainless steel or glass polymer or composites. However, in the past decades, biomaterials have gained its strength as one of the materials to be used for implants. So, pwede na maging bioactive. Before, whenever you have a sutures, kapag nasugatan ka, may suture, yung tahi, diba, you go back to the doctor after a while, 1 month, para tanggalin niya ulit yung tahi. But now, you don't need to do that because we have sutures that are bioresorbable. So, nare-resolve na lang sa katawan mo. You don't need to get to see your doctor and then remove that suture. Ayun, bioresorbable na. And last but not least, of course, is that, okay, this is just a summary of the 6 classification of materials. Actually, at the end of this subject, I'll be requiring you to report on this engineering materials tackling the 6 properties. Though I'll be discussing those properties first, and then you'd apply that or discuss that in your project. Kung sa'yo si metal, you'll be discussing about the different properties, yung optical, thermal, mechanical properties of that certain engineering material. Okay, as I've mentioned, advanced materials are gaining its popularity right now because of the utilization of high technology applications, or they are used for lasers, um, ICs, LCDs, and the newest is what we call as your smart materials. So these materials are a group of new and state-of-the-art materials being developed using sensors and actuators. Why it is termed as smart material? Smart implies that these materials are able to respond or able to sense. Kaya nga meron silang sensor and actuator. So they are able to sense changes in their environments and then respond to these changes in predetermined manners. It's like, for example, you have a car, a smart car, that whenever you put a very high impact, tapos magde-dent siya, but after a while, pag na-sense niya nagkaroon siya ng dent, the actuator would act and then babalik lang siya sa dati. So those are smart materials. So it performs, the actuator would perform a responsive and adaptive function to that stimulus that you apply. Okay, so those materials that are utilized in high technology applications, sabi ko, are term advanced materials. They are devices or products that operates or functions using relatively intricate and sophisticated principles. So mga high-tech. Kasi this implies already yung mga AIs or artificial intelligence. Okay? So I think that ends the introduction for this lecture. I just hope you have a bit of a knowledge already of what engineering material is. And if you have any question, feel free to do it so, or any clarification with the lecture. As I will be meeting you again after you had your poll kung ano yung schedule na gusto niyo, if it is Monday or Wednesday, or retain it on Saturdays. Are there any questions? The 31 students right now here in the class.
None po, ma'am.
Ouch. Whenever your faculty would ask if there are questions, say, I've been to so many speaking engagement already. The greatest fear for a speaker is when there are no questions asked. Why? There are just two things that could happen. One is, if the idea that the lecturer have imparted to the audience is very well understood, no questions, or nothing is understood. So, saan ako matatakot sa inyo? Naintindihan lahat o walang naintindihan? It's just an introduction ng engineering materials. Lahat naintindihan ba? Hello, can you open those who could open their cameras, can you open? Para makita ko naman kayo. Ayan, si Clarence, nakita ko. Lahat naintindihan o walang naintindihan? Either of the two. Are you talking, Mr. Banan? Kasi parang
Naintindihan po, ma'am.
Okay. Lahat naintindihan?
Yes, ma'am.
Yes? Okay.
Yes po, ma'am.
Yes po, ma'am.
Mag-quiz na
Yes
tayo.
po.
Mag-quiz na tayo?
Huwag naman, ma'am.
Okay.
Yes, ma'am.
Next meeting
Joke
po.
lang.
Okay, sige. Let's reserve the quiz next meeting. So it's all about what I have discussed today. And then just siguro see up to what extent your knowledge in engineering materials is. Okay? So So please, Mr. Tagakay, just send me the screenshots later. Should I? Okay, thank you very much. It's time for me to go home. I'm still here at Mango Sweet since this morning. So mahirap na wala tayong kuryente. Okay, so I want you to reserve your data allowances. Let's call it a day. Have a nice weekend and see you again next week. Thank you so much. Bye.
Thank you
Thank
po,
you,
ma'am.
ma'am.
Thank you
Thank
po,
you po,
ma'am.
ma'am.
Ma'am, bye
Thank you,
po.
ma'am.
Please
Thank you
sa likod
po.
ni